Powers of monomials. Vic number 1, power of a power. To find the power of a power, multiply the exponents. So we have 6 to the 4th power raised to the 5th power. This means that there are 5 factors of 6 to the 4th power. So 6 to the 4th power is multiplied by itself 5 times. Now, from a previous lesson, you know that you keep the base and add the exponents when multiplying. So I have 6 as my base, and I'm going to add all of my exponents together. Add all these 4's together, and you get 20. Now, the Vic says you can take a shortcut and just multiply the exponents. So 4 times 5 gives you 20. A power to a power, multiply the exponents. Example 1, 8 is the base, 8 to the 4th power raised to the 3rd power. A power to a power you multiply. So 4 times 3 gives you 12, 8 to the 12th power. Now if you try to type this in your calculator, it may give you a very, very large number and may not be able to do it. So leave it as 8 to the 12th power. Example number 2, k to the 7th power raised to the 5th power. A power to a power you multiply. So 7 times 5 gives you 35, k to the 35th power. It works the same with numerical bases and variable bases. Algebraically, it would look like this. A is the base, a raised to the m power, raised to the n power. So you just multiply whatever m and n are together, a to the mn. Vic number 2, power of a product. To find the power of a product, find the power of each factor and multiply. Now we have more than one thing inside our parentheses. We have 3 and we have an a. These are both different bases. So 3 is a base and a is a different base. In order to find the power of this product, you're going to find the power for each factor, so for the 3 and for the a, and then multiply. So this means 3a squared 5 times. 5 factors of it. Now, you can group them all together and put the 3's together. 3, 5 times, and your a squareds, 5 times. And then you can simplify it this way. So 3, 5 times is the same thing as 3 to the 5th, and a to the 2nd, 5 times also. 3 to the 5th power, you can type this in your calculator or you can do it by hand. That's 243. And a to the 2nd power raised to the 5th power. A power to a power you multiply. So 2 times 5 gives you 10 here. So 243, a to the 10th power. Example number 3. 4, p to the 3rd, all raised to the 4th power. The 4 gets the exponent also. So using a shortcut, I know that this 4 is a base and p is a different base. I don't see an exponent on 4, but I know there's a 1. Remember, if you don't see the exponent, it's a 1. A power to a power, you multiply. So 1 times 4 gives you 4. Keep the base. Look at the other base. P is the base. Power to a power, you multiply. 3 to the 4th power, p to the 3rd raised to the 4th. Multiply 3 times 4, and you get 12. 4 to the 4th power is 256, so we have 256 p to the 12th power. Example 4. The quantity -2 m to the 7th, n to the 6th, all raised to the 5th power. Now there's a lot going on here. Remember that -2 has an exponent on it. It has a 1. So we're going to say 1 times 5 is 5. M's, look at your M's, 7 times 5. That gives us 35 right here. And n, 6 times 5, that gives us 30 right here. So n to the 30th. -2 to the 5th power. You have to have parentheses around this -2 because it's -2 times -2 times -2. And if you don't have the parentheses, then you may get the wrong sign. Okay? So make sure you put -32. In algebraic form, the rule looks like this. The quantity AB raised to the m power. The A gets the exponent, and so does the B. So A to the M, B to the M. 2 to the 5th power, 2 to the 5th power. 2 to the 5th power is 256. 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 2 This is very much like Vic number 1. It's just more than one thing getting the power rule. Okay, power of a power rule.